Welcome to the DIY Honda Garage channel. Welcome to this diagnostic presentation focusing on DTC P0332, which indicates a low voltage issue in the circuit of knock sensor 2, specifically for bank 2 in Honda Accord models from 2012 to 2017. The knock sensor is a critical component that monitors engine vibrations to detect knocking or pinging, which can significantly affect engine performance and efficiency. Located on the engine block, the knock sensor converts vibrations into electrical signals to communicate with the powertrain control module, PCM. This module is responsible for controlling ignition timing. Hence, any malfunction can lead to performance declines or increased emissions. Understanding this DTC and following systematic troubleshooting steps will help restore normal engine function and performance. After resolving DTC P0332, implementing preventive maintenance is essential to avoid future issues with knock sensor 2 and its circuit. Regular inspections of engine sensors should become part of routine vehicle maintenance, ensuring they remain in optimal condition. Additionally, routinely checking the wiring for signs of wear or damage can prevent short circuits or connectivity issues. Keeping the connectors clean and ensuring secure connections will help maintain proper electrical signals, minimizing the risk of DTC reoccurrence. By integrating these preventive practices into your vehicle care, you can enhance engine performance and longevity and maintain efficient functioning. In conclusion, DTC P0332 highlights the importance of the knock sensor in maintaining engine safety and performance in Honda Accord models from 2012 to 2017. Understanding how the sensor functions and identifying symptoms of malfunction can lead to timely and effective repairs. The systematic troubleshooting steps outlined allow for a thorough diagnosis, ensuring that the root cause of the issue is addressed effectively. Additionally, by adopting preventive maintenance practices, you can prolong the lifespan of the knock sensor and overall vehicle performance. Ultimately, a combination of accurate diagnostics, effective repairs, and ongoing maintenance will help ensure that your Honda Accord runs smoothly and efficiently for years to come. DTC P0332 indicates a malfunction in knock sensor 2, which is positioned on the engine block specifically for bank 2. Its primary function is to detect engine knocking, a phenomenon that can cause damage if not addressed promptly. The sensor uses a piezo-ceramic element to convert the vibrations from knocking into electrical signals. These signals are then transmitted to the PCM, which adjusts the ignition timing based on this information. Under normal conditions, the knock sensor should output a specific voltage. However, a voltage of 0.5 volts or lower for at least 2 seconds triggers the DTC. This discrepancy in voltage can lead to severe performance issues and potentially endanger engine components if not resolved. There are several potential causes for DTC P0332 that need to be evaluated systematically. Firstly, the knock sensor 2 itself may have failed. This is often due to wear over time or manufacturing defects. Secondly, the KSB2 line, which connects the sensor to the PCM, may have a short to ground due to damaged wiring or connectors. This can create a direct pathway to the ground, preventing proper voltage from being transmitted. Lastly, the PCM can experience an internal circuit failure. A malfunction in the PCM circuitry can lead to erroneous readings or the misprocessing of signals from the knock sensor. It is crucial to methodically address each potential cause to accurately diagnose the issue. When DTC P0332 is triggered, there are noticeable symptoms that can affect vehicle performance. The most immediate symptom is the activation of the check engine light, which serves as a warning to the driver. Poor engine performance may also occur, marked by irregular acceleration, increased fuel consumption, or issues maintaining speed. Another critical impact is the increase in emissions, which may cause the vehicle to fail an emissions test. Ignoring these symptoms can lead to more significant engine issues or damage, making it imperative to investigate the cause of the DTC promptly. The first step in troubleshooting DTC P0332 is to inspect the wiring and connectors associated with NOx sensor 2. This physical inspection is crucial, as damaged wires or corroded connectors can cause malfunctions. Look for any visible signs of wear, pinching, or fraying on the wires, as these issues often lead to poor electrical connections. Additionally, make sure that the connectors are securely attached and free from corrosion, which can interrupt the flow of electrical signals. Any finding here may indicate the need for repair or replacement, which could resolve the DTC without delving deeper into more complicated diagnostics. In the second troubleshooting step, you must measure the voltage levels at NOx sensor 2. This involves using a multimeter to check the output voltage while the engine is running. The expected voltage should be above 0.5 volts. If it falls below this threshold, it confirms a possible fault with the sensor or its connection. Record the voltage readings and compare them to the acceptable operating levels specified in the vehicle's service manual. Identifying discrepancies in voltage helps narrow down whether the issue lies with the sensor itself or if it can be traced back to wiring or the PCM. The third step focuses on testing the functionality of NOx sensor 2 itself. To do this, an oscilloscope is used to evaluate the signal patterns outputted by the sensor. This allows for a detailed analysis of how the sensor is responding to engine vibrations. By comparing the waveform patterns to established benchmarks, you can diagnose if the sensor is operating correctly. If the signal is irregular or absent, it likely indicates that the NOx sensor is faulty and may need replacement. Properly assessing the sensor's behavior provides important insights into the nature of the DTC and directs the subsequent repair process. The final troubleshooting step involves inspecting the PCM, which is the electronic brain of the vehicle. To ensure that it functions correctly, check for any known internal failures, which may prevent it from correctly interpreting signals from the NOx sensor. In some cases, issues may be resolved by reprogramming the PCM with updated software, particularly if there are known bugs affecting performance. If the PCM is found to be faulty and unresolvable through these means, replacement may be necessary. This step is critical, as a malfunctioning PCM can inhibit engine performance and fuel efficiency, aggravating any existing DTC issues. Once repairs have been completed, the next step is to verify the repairs effectively. Start by clearing the DTCs using a professional scan tool. This resets the vehicle's computer systems and allows the ECM to monitor operations afresh. After clearing the codes, it's essential to perform a test drive under various conditions to ensure that the repairs have resolved the issues. Pay attention to any warning lights reactivating, as this could indicate a lingering problem. If the DTC does not reappear after multiple cycles of operation, it confirms that the issue has been effectively resolved. This verification step is crucial to ensure reliability and longevity of vehicle performance post-repair. Please like and subscribe to the channel. See you next time.